you're going to notice that I have several handouts attached for you. So it's very, very important to probably print these out because it will help you. The test should have opened up for you to see what you missed. Let me know if you were unable to do that. I also wrote you guys some extra information since some of this will be going on with your exam. And it'll get here before we know it. But I put down some things here like CL for class limits and how to figure all that out, and CB class boundaries, frequency, and some of the symbols and things that you'll see in stats to know what it's asking for. So I thought that might help. On the back of this, also from the past test, I also attached the graphs kind of to show you what those were called. So your histograms with your bar graphs, your relative frequency bar graphs, your polygons, and those kinds of things, and your ogives. Because if you have to take another statistics class, I would highly recommend keeping these handouts and putting these in a safe place, because eventually, when you finish this course, if you're not going to SCC, you might lose some of this information that's in your D2L. So especially you seniors, I would probably start organizing this and printing this out into a notebook. Now, this was something that we talked about in the last lecture, this second handout that you see here, and kind of putting it together. Now, we haven't gotten to interquartile range, so don't worry about that quite yet. We will be getting to that. But this will help you with your graphs and kind of with the skew and knowing what to pick. So I thought this would be a good handout to get you guys. If it's left skewed, you remember your data is going to be kind of more on the right, and you're going to have some skew on the left. And then right skewed, you're going to have that skewed to the right. Look for where your tail is. And those outliers are going to affect the mean. So remember, the best appropriate measure of central tendency would be the median. So that might help you with some of that, with reminding you of what to pick. When it is symmetric with some outliers, you're going to ask yourself, is it symmetric with a few outliers, or is it just symmetric? So if there's not any outliers, then you could use your mean or median. Both work pretty good. Mean is the most common used. We're going to talk about standard deviation today, and interquartile range will be in the next lecture. If there are some outliers, again, median is going to be the best. Okay, so as you kind of look at those, I would print this chart out too to help you with putting things together with central tendency in the spread of your data. So where we're going to start next is I want you to find this handout, and I'm going to have you write down the symbols here with me. And you normally use what's called Greek symbols when you're dealing with population, and you normally use the English symbols when you're dealing with a sample. So there's different statistics symbols that are used, whether it's a population or a sample. So I thought this might be helpful as well. So I'm going to let you copy those. This stands for variance of a population. This stands for the variance of a sample. With the standard deviation, you square root the variance. With population, this would be your Greek symbol for a mean, mu. Your sample symbol is the X bar. Population, you use a capital N. sample, you use a lowercase n. That's how many entries of data that you have, or how many people you've actually sampled. Deviation is how far each value deviated from the mean. So this is x minus your mu, and that's x minus your x bar. And I'll let you copy your sum of squares. Remember, that's standing for your mean, and that is your summation symbol. Now, before we start the actual notes, this part is not on a handout, but it's something that's very important. So you probably want to write this on a sheet of paper. So today we're going to be focusing on variation. When you think about variation, how something varies and how something is different from something else, with stats, you're going to look at how the data is spread. Now, if this is going too fast, you can pause and go back and kind of copy this down, okay? But you do need this information because it'll help you with some of your questions on your test, quizzes, and homework. When you deal with the range, you take your maximum value and you minus your minimum value. So that's just your high minus your low. When you do a range, it doesn't consider all the values within. So it just does the high minus the low. So it could affect your range because depending if that high is really high compared to the other data or the low is really low, sometimes range is not the best measure. Standard deviation, and you'll probably see this because you probably noticed some of your stats questions are not working out. It's more based on understanding at times. So standard deviation is your most useful measure of dispersion of data. And that is because it takes into consideration all of the values. It is the standard distance to the left or right from the mean. So wherever your mean is, it's going to take into consideration every value and the distance every value is from the mean, not just the high and low. So it's going to do a calculation with every single value to give you the best approximation for the variation. Now, this part is very important. If you have a low standard deviation, if you have a low standard deviation, or you have a high standard deviation, a lot of people miss this on the questions. So if you have a low standard deviation, that means that you have most of your data that's closely grouped to the average, which means that that's going to be the most reliable. When you have things that are varied outwardly and the data is more spread out from the average, it's not going to be as reliable. So what you want to become more reliable is you want a low standard deviation. That is going to be the most reliable. That comes with closely grouped data. Closely grouped data. So I put all these little data points that are very close to the mean. Here I put data points that go out far from the mean, which are away from the average. The spread out data would be less reliable. That's going to occur if you have a high standard deviation. That's going to be spread out more. So sometimes you're going to have to calculate the standard deviation and tell if it's reliable or not. So you really need this part of this information. And remember, that's the most useful. and it takes into consideration all the values. So pause that if you didn't have time to copy, please, and make sure you have that information for your notes. Now we're going to start section 2.4 today. So this part will be the part that you will upload to me. The other part is just information to help you with the unit, to help you with your grades. So first of all, we're going to talk about population variance and population standard deviation. Make sure you kind of highlight this part of the notes because a lot of times people get confused, and the reason I highlight that is we tend to sometimes overlook what it's saying here, because on the bottom part, that's why I'm doing this one with you, the bottom part deals with sample. So there's going to be different problems that are going to say sample, and some of them are going to tell you population. And depending on what that is determines what formula you use. So you have to pay attention to the words sample and population, okay? Okay, a population variance is going to be the mean of the squares of the deviations. So your population variance, you're going to add up, that's the sum. You're going to take each data value, you're going to subtract it from the mean, you're going to square it to make sure we have positive values dealing with distance, and we're going to divide it by the capital N because capital N deals with the population. Okay, now that's going to be your variance formula. For population. Okay, over here is your population standard deviation formula. Now what you're going to do here is you're going to take the square root of the population variance. Okay, so what you're going to do here is you're going to take the square root of whatever you get here. So I'm just going to put all of that under the square root symbol. So it is the same formula. You're just going to square root that answer. Okay, so what we have here is you're going to notice in your questions, it's going to tell you those words. So we know we're dealing with population. Okay, that tells me that I'm dealing with the population for these 4 salaries. There must be 4 employees at this company, and we're dealing with every one of those. So it should tell you again your population. So we're dealing with population. So please pay attention to these words when you do your work, okay? So what we need to do first is we're going to put the data entries. That's going to be your X. So I'm just going to rewrite 31.9. The next one is 36. And then we have 35.1 and lastly 25. So that's going to be the data. I need to figure out the mean. Well, this goes back to the last lesson that we learned with that lecture on mean. So you have to ask yourself, is this grouped data or is this ungrouped data? So basically this would be ungrouped data. So to get an average for that mean, you're going to add all those and divide by 4. So you have to remember how to do those averages. And remember I gave you a formula sheet So if you need to get that formula sheet out as we're working today, don't forget that. That might help you. So I'm calculating the mean. So I'm adding all of those up, and I'm going to divide by 4, and I get 32 for that average. Okay? So this is ungrouped data. I'm adding those up and dividing by 4. So 32 is going to be the mean. Now that average is the same for all of those because it's the mean of all 4 of those. Okay? Now what I was mentioning a while ago is deviation is how far each x value is from the mean. Okay? So you're going to take each x value and you're going to subtract the mean from it to see how far away you are. So you're going to take 31.9 and subtract 32. Okay? So go through and subtract all those, and I'm going to demonstrate. So the first one, I believe, was 31.9, and I'm going to subtract 32, which is negative 0.1. Then I'm going to do 36, and I'm going to minus it from 32, which gives me 4. So I'm seeing how far away each point is from the mean. That one would be 3.1 and negative 7. Okay, so next, we're going to have to square that. So I want you to kind of focus with how the table is based on your formula. So if you notice right here, I took each x, okay, each x value, and I subtracted the mean. Okay, make sure you kind of follow that because you don't have to build a chart for every one of these problems. You can just kind of use your formula. The chart's helping me show you how to do the information. Now, sometimes you might find that they'll have charts for you also to fill out these tables on your work. But if they don't, you can go through and kind of just utilize your formula, whichever way you organize the best. Now notice with that formula, I square it after I subtract. So that's why it says here, squares. Now, one thing you gotta be careful of, if you don't remember me mentioning a while ago, the reason you're squaring it is you're dealing with positive numbers for distance, no matter if it's to the left or the right of the mean, okay? So when we square this, it needs to be positive. So please don't forget to put that in parentheses if you're squaring, where it will square the negative also. So that's going to be a 0.01. 4 squared is 16. 3.1 squared is 9.61. And negative 7 times negative 7 is 49. Okay? Now, once you have done that, if you recall what I told you a while ago about that symbol, that means we're going to add up all of the squares. So we're going to add up all 4 of those and put that number right there. So go ahead and add those up. And I'm getting 74.62. Okay? Now, what happens next is, a lot of people say, well, that's the answer. No. Please look right here. You have to divide, okay, by how many entries there were. So if I go back to my data values, we look at how many n's there were, okay, so how many x's. So the capital N, because its population was 4. So I'm going to have to divide that by 4 when I get over here, okay? So we're looking at population variance. Pay attention to the left side right here, okay? I'm going to bring over my symbol, and I'm going to have 74.62, okay, which was my sum. I'm going to divide it by 4 for the population. So go ahead and do that. And we get something like 18.655. Okay? Now, When you get to the population standard deviation, if you look at those right there, all we're doing is taking the square root of this answer. So if you go back to where I wrote that, you're taking the square root of what you got for the population variance. So I'm going to go back to this, and I'm going to do second square root, and I'm going to call back up my answer, and it would be 4.319. Okay, and I'm going to put approximately because I rounded with that one. So approximately 4.319. Okay, now pay attention to what the computer is asking you to round to, okay? So whenever the computer is asking you to round to a certain place, if you don't round correctly, you will mess up. So please pay attention to rounding, and also pay attention to if it's 5 or more to bump this up. So if the computer program wanted you to round this one to 2 places, then it would be approximately 18.66, okay? So be very, very careful. If it wanted you to round to 2 places here, it would be approximately 0.432. So pay attention to those numbers of whether it bumps up or not. Okay, that's how you do population. Now we're going to take a look at the sample. Okay, here is the formula for sample variance. Okay, notice that it's almost the same, except we're using different symbols, and we're also dividing by an n minus 1. When you deal with a sample, since it's not everybody in the population, the n minus 1 represents a degree of freedom, which helps you get a little bit closer to what the population would have been. So you do divide by n minus 1. So you take your sample and subtract 1 from that. Okay? When you go to this part, okay, you're just going to take the square root again. So what I'm going to put is the standard deviation or the sample is going to be the square root of all that. So I'm just recopying that over. Okay, now again, it's going to tell you, so here it says find the sample variance, and I need you to change 2 things before we begin. I need you to go to the very bottom of the page and change that to sample and sample. So when you're doing your work, that's not confusing because that was a typo. So change both of those at the bottom to sample and mark out population. Okay, so I'm going to use the same data entry. So this time we're going to say they took a sample of employees at the company. They didn't do the whole population. So we're going to have the same numbers. When you calculate the mean's going to be done the same way because it's just 4 numbers. We add them up and divide. So my means are going to be the same. My deviations are going to be the same. My squares are going to be the same. My sum of my squares are going to be the same. Okay? You might be saying, well, why am I doing this? I want you to understand that it's going to be done the same way except what you divide by. Okay? So don't let it confuse you. It's just when you deal with a sample. Okay, that's my sum of my squares. My n is equal to 4. This time, if you go back to your formula, you're going to divide by 4 minus 1 when it's a sample. So you're going to divide by 3. It's going to help you estimate this a little bit larger because we're not taking into consideration the whole population. So therefore, our answer will be estimated a little higher, and that's called the degree of freedom. So we're going to divide that. So take that and divide that. And I'm getting 24.873. So what I'm going to do to deal with the rounding, to show you, is I'm going to round 2 places right here. So I'm going to say that's approximately 24.87. Now, I want you to understand when you go back and do the square root to get this one, do not go to the rounding one, okay? You need to do second square root and call it the whole entire answer. So you need to call it the whole entire answer when you square root it to get your standard deviation. So then after you do that, you would round from this point if you were rounding 2 places, and that 7 bumps that 8 up to a 9. So this would be S is approximately 4.99. And if you recall, this was S squared, okay? So notice that's estimated a little bit higher since we didn't have the whole population, we had a sample. Okay, the only thing different again is to make sure that you divide by n minus 1. And again, I wrote this down for you if you want to copy this. When you deal with an estimate, a sample mean sometimes leads to bias. So that's why you divide by n minus 1, which is called a degree of freedom, because sometimes data and these values vary from sample to sample. So this n minus 1 is called an unbiased estimator. So it helps kind of decrease your bias. And again, when you divide by n minus 1, it makes it a little larger to help with your estimate. Okay. So now we'll go to, I think the back of that deals with a calculator. Okay, let's take a look at what the calculator steps tell us to do. It tells us to hit stat enter and enter the data values in L1. So L1, I'm going to type in those numbers above. 3, 4, 7, 8, 11, 12, 12, 15, and 19. Okay, go ahead and make sure you go grab your calculator if you have not gotten one yet. Then you're going to hit stat, you see right here, arrow over to calculate. Choose 1 bar stats. Hit enter. Okay, continue hitting enter. Okay, right here, this will tell you some information from this question. So I'm going to point out what these things stand for, okay? So first of all, the SX right there, that stands for your sample standard deviation. So this right here is considered your sample standard deviation. So I'm going to say that that's approximately, I'm going to round one place this time, and I'm going to say approximately 5.2. That's your sample, okay? If I go down here, this one right here is my population standard deviation. So right here, that's sample. The population uses this symbol here, and we're going to say it's approximately, that 6 will bump that up to a 9, 4.9. Okay, now let's say that you want to know the variance right here. Well, if you recall, the standard deviation is the square root. So the variance, you're going to square it. So this one right here was dealing with population. So let's take this number, and what I would do to try to get a good number with that is on a scratch sheet of paper, I would do 4.8635700806. And I would type that in, 4.8635. And then you square it, and you get approximately 23.7. And if you take the square root of that answer, oops, I hit square again. Square root of that answer, wait a minute, second square root, second answer. You get that 4.9 that we had. Okay? With the sample, you would do the same things. We'll go to stat, number 1, bar stats, and I see it's 5.158595,847. You want to type in that whole number right here where you'll be more accurate, because you could mess up if you're off just a little bit with decimals. We'll square it. So that would be approximately, if I round that, 26.6. So S squared, 26.6 approximate. Okay, so that's how you can look in your calculator. I'm going to put you this note up here to help you too, and I want you to write at the bottom of this. So with deviations, this SX is your sample standard deviation. Then you have your theta X, which is your population standard deviation. So it's not going to give you the variance, because if you recall, the one that's most useful is going to be the standard deviation. So that's the one that the calculator is going to give you. Now, some of you might be asking what those other things stand for, so I wrote this down for y'all. When you have ungrouped data, this right here deals with your sample standard deviation. You need to square it to get your sample variance. Then you have your population standard deviation. You need to square it to get your population variance. You have your X bar, which is your mean. You have your sum of your X's. That's what that means. You have your sum of your X squareds. And N is your number of data entries. Make sure you pause that if you're I'm going too fast for you to write that down because that stuff's important for you to understand. Okay, so what I want you to do is, as you do number 2, 3, and 4, okay, I want you to go through those before you upload your notes, and I want you to make sure you submit me those answers. So before we do that, I want you to go on the left side and put sample. And we would have like SX, and you put that. And then you would have to square that to get your other one. So I want you to do your sample, and then over here with that same data, just ignore that. That's what I wrote down a while ago. You're going to put population. So I want you to do that for both of these questions below. So you're going to have sample and population. Okay, it tells you exactly how to type it in right here to your calculator. You're going to find those values, and let's round off about one place, okay, around one place, and I'm going to walk through one more with you and then divide up number 3 and 4 just like this, okay? So go back to your calculator because I want to remind you how to clear this out. Hit Stat and Enter. To clear out a list, you go to the very top. You're going to match Clear Enter. Okay, now I'm going to type in the data, 52, 47, 60, 55, 58, 53, 59, and 63. Then I'm going to hit Stat again. I'm going to scroll to Calculate. Number 1 bar stats. I keep hitting Enter till I get to this portion here. This would be my average, which is my mean. That's the sum of the x's if I added all the x's up. That's the sum of all the x's squared. This is my sample, standard deviation. This is my population, standard deviation. So let's go ahead and round those to one place like we said. So the sample would be 5.1 and the population would be 4.8. So I'm going to put in approximately. I think I said 5.1, and then the sample was approximately 4.8. Now you're going to need to type those in and square it for your variance. So you would need to write down those numbers somewhere. And I'm going to write those down. I'm going to write down the sample first. And then I'm going to type that in. And when I square that, I get approximately 26.4. Okay, then I'm going to go back, and I'm going to go back to calculate with that. I'm going to now write down my population one, which was 4.807 221131. And I'm going to square it, and I get 23.1 approximately. Okay, so I want you to try those two. Make sure that you have a calculator, okay, because you will need that with some of the problems we're fixing to be doing. So please try to get you one of these calculators to use and get used to those steps, okay? Okay, going to the next portion, we're going to look today at finding the standard deviation if the data is grouped. Now, when the data is grouped, that means that you actually have it in a table, okay? So it's kind of grouped together in a table. So I'm going to kind of box this in. Please do that also because I want you to understand the one we did earlier on the calculator and by hand, That was not grouped, okay? This is grouped, okay? So the formula for grouped is going to be different. Okay, you're going to use this formula for your grouped data, okay? Now, when you use this formula, I want to explain to you kind of what's going on with this table. Rather than listing this out for this sample, okay, they're telling you how many times it occurred. So what this means is 0 occurred 3 times. Okay, so that means you have 0 3 times. You have 1 15 times. Okay, you have 2 24 times. And you have 3 8 times. So you don't want to write all that out sometimes. So sometimes it's organized in a table. Well, if I have 0 that occurs 3 times, think about that for a minute. If I have 0 that occurs 3 times, the total of that's going to be 0. Okay? If I have 1 that occurs 15 times, that's going to be 15. If I have 2 that occurs 24 times, I don't want to type all that in every time. So what you can do is you can multiply those together. So if 1 occurred 15 times, rather than adding that up 15 times, I can multiply 1 to 15 and get 15. Rather than adding 2 24 times, I can multiply that and get 48. Rather than adding 3, 4, 5, 6, 7, 8. Rather than adding 3 8 times, I can multiply that together and get 24. Okay? So it's kind of shortening you having to add all these because this is a lot of entries. If you think about this, it's a lot more than those that we was dealing with a while ago. I think we had 4 data entries. Right here, if 0 occurred 3 times, 1 occurred 15 times, let's think about how many things that we're having here. So what would the sum of that be? So let's add those. So we got a 3, a 15, a 24. What else do we have? And an 8, right? That's 50 data entries. So we actually have 50 data entries. Okay? That's going to be like my N. Okay? I have 50 items because the frequency is telling me how many entries are in that data. So this is like the N. N is going to be 50. Okay? 50 entries. Now, when I think about this, I'm going to look and see what this question is actually telling us. It says that the results of a random sample of the number of cars per home in a region are shown in the first column. So what this means is there were 3 homes that had no cars. There were 15 homes that had 1 car. There were 24 homes that had 2 cars. And there were 8 homes that had 3 cars. Okay? So when I'm thinking about that, I always read the question because that'll actually give you an idea of what's going on. So there were 50 households that were actually polled in this data that was organized in this table. Okay? So I have to think about, well, I got to get a mean from this. I got to figure out what an average for this would be. So I have to think back of how I got an average for the last class. So how do we get an average or a mean when the data is grouped like that? Well, do you not remember when we did that? We took the sum and divided by the number, okay? So if we have to get an average, we're going to take the sum of your x times f, and we're going to divide that by your n. So we need to add up all of those right there to get that average. So we're going to have a 0, slide over just a little bit, 0, 15, 48, and 24. So we have a total of 87. Okay. Now I divide that by 50 because I have to find my mean to be able to subtract each x from that mean. Okay. So now when I divide that, let's round it. So we're going to have 87 divided by 50. And let's just keep it 1.74. So it came out 2 places. So we'll keep it as accurate as we can. So that's going to be my average. So what I'm going to do with this is I'm going to take each x and I'm going to subtract the average. So you have to know how to do this first before you can actually do anything else with this equation. So that is why it's very, very important that you don't forget the formulas you learned the previous lecture. So now, if you notice in this formula, I'm going to take each x and I'm going to subtract the average. These are my x values. Be very, very careful. Some people like to go back to the frequency side. So we're doing your x value minus your mean. So you're going to have 0 minus 1.74. And that's going to be negative 1.74. Okay, try to finish that column with me. So my next x value was 1. I'm going to minus my mean. My next x was 2 minus my mean. My next x was 3 minus my mean. Okay, now if you remember, we're going to square it where we're dealing with positives for the distance, whether it's left or right distance. So when I square these, don't forget to put a parenthesis around it. Now, please write down every value you see. And just double check yours with mine. If you ever notice a mistake or have a question, just let me know. Okay, and then the last thing, if you remember, it occurred so many times. So I've got to make sure that I multiply to how many times it occurred. And notice my calculator is right there with that frequency. So I'm going to take, okay, I'm going to take what I just got right there in that box, and I'm going to multiply it to the F. Okay, notice the F is right there. Okay. So I'll show you the first one, and then you might could go ahead and try the other ones with me. So I'm taking that, and I'm multiplying. That occurred 3 times. And then I'm taking my next number, and that occurred 15 times. my third number, that occurred 24 times. And my fourth number, and that occurred 8 times. Oops, I think I hit something wrong there. That doesn't look right. That was supposed to be 1.5876, and that occurred 8 times. That looks right. Okay, now I'm going to go back to my formula. Remember, this is the formula, okay? So notice I have already done this part right here. I've multiplied f to the x value minus the mean. This tells me I need to sum that up. So I need to go down here and I need to sum up those values. So I'm going to add up all of those. So my sum is going to be 31.62. Okay, so the sum of all that's 31.62. Now, when I look at that problem next, I take the sum of that, okay, which is 31.62, divide that by n minus 1. Now, if you remember, my n was 50. So 50 minus 1 is 49. Then I take the square root of that. So we'll put S equals, I'm going to type all of that in together and then round that, okay? So I'm going to have the square root, put in parentheses, 31.62, divided by parentheses 49. So I get, and I'm going to round, I think, let's go 3 places for that. So 0.803. So you can see that takes a little bit of time. So this formula, as you're going through to utilize that formula, that's if your data is grouped, okay? So that's if you have grouped data. Don't forget, right there, if the stuff's grouped in a table, that you have to take the square root, you add up all those, multiply it to the frequency, multiply that to frequency, add them up, and divide by n minus 1, because it's a sum, okay? So you got to do that whole entire formula right there. So let's try this other one that's actually dealing with group data, but it's dealing with classes, okay? So this is dealing with classes, where we had like an upper class and a lower class and those kinds of things. Now, we're still going to use the same formula, but we're going to have to think about it a little bit differently, okay? Now, in this case, what I want you to think about is if I had something in the 0 to 99 class, and it occurred 380 times, I definitely don't want to write that out 380 times. And I really don't know what fell between that class. So what you have to do in this case is you have to find what's called midpoints. So put an X with a little m below it, because if you have classes, you have to first find out what the midpoint of that class is. Sometimes they're not going to give you the midpoint in the table. They might just give you the class and the frequency. And you say, well, I don't really know what to use for my X. Well, in that case, you use what is called a midpoint. So you estimate what is in the middle of that class. So if you think about that midpoint, you would have 0 plus 99, and you would divide that by 2. That would give you that 49.5. Then you would have 100 plus 199, and you would divide that by 2, and that would give you the 149.5. So you have to remember that formula. That's going to be your X, okay, when you're dealing with classes, okay? So what you do next is you do just what we did above, but now that you know your X, you're going to take your midpoint. So I'm just going to change this right here. It's going to be XM times F. So you're going to take what that midpoint was, and you're going to multiply to how many times it occurred, okay? So before we kind of start doing that problem, let's see what the question is stating. You have a random sample, so we're dealing with sample, of the spending habits in preparation for travel in a region, okay? So we have spending for people that are traveling. We have different classes, okay, of that. Spending habits. So if I look, I'm trying to figure out how many people might have been polled here in this sample, because we always know that there's a certain number in a sample that was polled. So if this occurred 380 times, that occurred 230 times, the frequency is going to tell me how many people were in the sample. So those numbers are going to be the same, just like earlier. Your frequency is going to tell you how many were in that sample. So let's add that up first. So we have 1,000. And you see why they probably put that in a table rather than list that ungrouped. Okay? So now I'm going to have to figure out the sample mean here in just a minute. So I know how many my N is 1,000. So I've got to figure out, if you remember a while ago, I got to figure out my average. I always have to do that first. That's what I taught you first, which is going to be your mean. Okay, if you look back above to find the mean of group data, you're going to take the sum of your X times F's, and you're going to divide it by the N. Now, when it's dealing with the table, your X is going to be the midpoint, okay? Your X is going to be the midpoint when you're dealing with this table with classes. Okay, so what we're going to do is we're going to do our multiplication. So we're going to do 49.5 times 380. And what you can do is go ahead and multiply these out and just kind of check back with my numbers. Rather than me read all these out, because these are getting to be kind of big numbers. You got 52,395 for that one. That was 970. Okay, so now what I have to do is I have to total all of that. So I have to get a sum of all those. And that's going to be 192,000. Okay. And I'm going to divide that by how many were in my sample. I think we said 1,000 a while ago. So that's going to knock off 3 of those zeros and give me a mean average of 192. Okay, so my mean is going to be 192. So that's what I'm going to subtract for each of my x's. Okay. Okay, so what I'm going to do here is I'm going to show you how you can go across and do your numbers if you don't want to go vertically. Some people like to go horizontally. So this x value was 49.5. And I'm going to subtract the mean, which was 192. So that would be negative 142.5. Okay, I'm going to go over here and I'm going to square it. That would be 20,306.25. Then I have to multiply that to how many times it occurred, which was 380. And we have 7,716,375. Okay? I'm going to go through the second one with you, and then you might just want to take off and check your numbers with mine, okay? So we're going to take our x value for this one. Remember, that was your midpoint. We're going to subtract the mean. I'm going to square it. I'm going to multiply it to the frequency. This time was 230. So that was 415,437. Okay, now we're to the third one. The x is 249.5. 249.5, and I'm subtracting 192. Square it. Multiply to 210. 694,312.50. Okay, the numbers are going to get bigger. Okay, so if you're going into business, you can see where stats is very important. You got to pay attention to all these little minute details. I enjoy dealing with all these different numbers. I was a bookkeeper at Milo and had to budget a bunch of things, so it's kind of fun at times to go back through this. So now we've got 349.5. We're going to subtract the 192. I'm going to square it. I'm going to multiply it to, that one was 50 times. Okay, and the next one I think was 449.5. We're getting there. Square it. Multiply to 50. Is that right? Or 60? 60 on that. $3,978,375. Okay, now the last one. I hope I haven't made a mistake. Okay, so this one was 599.5. Subtract the mean. Square it. multiply to the frequency. Whew. Now we got 1,162,3,937.5. $11,623,937.50. Okay. Now we get to add up all these things. So we're doing the sum of all those added up. I think I put an extra decimal there. 694,312.5. Okay, so I got 25,668,750. Okay, so I've got the sum of that. If I go back to my formula, I'm going to come down over here, okay? I've got 25,668,750. And remember, with the sample, we're going to divide by n minus 1, okay? So we had 1,000. So we take 1 off of that, it'll be 999. And we're going to take the square root to get that standard deviation, okay? So I'm going to go to second square root, second answer, divided by 999. So I'm going to round, we'll round 2 places for this one, so it'll be 160.29. 160.29. Okay, and that one was pretty tough. It's really not that hard. It's just basically having the patience to go through all those numbers. And that's the tough part. It's more mental and making sure that you're careful and not making a mistake, because you got to pay attention to detail. So this is the part that you'll upload today. So you'll upload through this page. So the next class, if you'll bring the other portion of the notes that I have attached for today, and we will work on what's called the empirical rule and take a look at that information. So today's lesson dealt a lot with tables and crunching some data. And I hope you enjoyed it and learned a little something. Have a great day.